Hello, my name is Zhihong. I'm in the group, the Morris Wong. This is a single group, so I do the presentation myself. Today my topic is signature scammer, which is based on asymmetric algorithm. As we all know, more and more information exchanges and data communication are based on the network, which has higher efficiency and higher speed than traditional communication methods. The problem is how to keep the safety of the data we transferred on the network. In order to do this, some cryptography technologies were used to keep the data integrity and conversation privacy. It is a set of rules which defines some very complicated mathematical calculations that can change the original data into the form that is really difficult for strangers to identify. Another key consideration is authentication. How we can know the sender is the right one. This is really a big problem, and this can be done on the verification of the signature that was obtained by the sender. So today we are talking about these signature scammers. This is my outline. The first part is introduction. In this part, I will introduce several signature algorithms and how digital signature was used in the data communication. In the second part, I will analyze three signature scammers on detail, which contains the working mechanism and these signature scammers. Then, some recent research on two digital signature scammers, which are ECDSA and Nitrogen. In the last second part, I will do a comparison on the energy and the memory cost of these signature scammers. Finally, a quick summary are given. Digital signature is a mathematical scammer which ensures the privacy of conversation, integrity of data, and provides authentication services for the receiver to verify the sender. And how a signature was used during the communication. It is apparently to see on the diagram. We can assume that the sender is Alice and the receiver is Bob. Alice chooses two keys. One is the private key and another is the public key. Alice composes a message and creates a signature using her private key and sends the message and signature to Bob. Bob uses Alice's public key to verify the signature. If the signature is valid, Bob can be confident that Alice is truly an author of the message, and if has not altered the message content. And there are some different kinds of digital signature scammers, and these scammers will be introduced in detail in the following part. First, we are talking about IC. In the history of digital signature, there appears a lot of different kinds of digital signature algorithms which have different efficient and operation mechanism. IC is the most widely used signature scammer, in which two selected prime digits are used in algorithm. They are used to generate private keys. On a set of special designed mathematical operations, the signature was generated, which was obtained from two computation by using the function f. The function f is a one-way function, which means that it is easy to compute but hard to invert. This can keep the security of the signature, which means that fake cannot get the original parameter in the signature easily. The security level is related to the prime that was chosen before. The larger the digit was, the higher the security level is. The next one is the DSA. It is also some communicate mathematical computations, and the difference is the hash function was used in the signing phrase and verification phrase. It uses information in the signature which has some parameters, and the verification phrase do the same computation and compare the result the receiver gets with the same communication result from that was get from the sender. Some improvement in the operation speed of DSA has been done, which name is DSA. That is clearly described in the diagram. The way to improve the speed is reduce the involves operation, which is very complicated and costs a lot of time. We can make a comparison of the mathematical computation with previous one. So it is apparent that then the next one is algorithm digital signature. It is based on difficulty of computation discrete logarithms. The hash function is used in this part. The operation is has a message m to obtain the hash value. Hash is H is the hash function. M is the binary message in arbitrary length. A random key was generated in the second part. We can use the random digits to get two values with R and S. So the signature is this pair of digits. The verification phrase is the same as the DSA. Compared with RSA, algorithm is more safe because algorithm use different random digit key. It means that in different data communication steps, different signature will be generated. Because if you use the same signature, it is more easy to be attacked. Next part is some recent research on digital signature scammer. First, I will talk about ECDSA, which use the elliptic curve cryptography. The security of the key depends on its size and its algorithm. Some algorithms are easier to break than others and require large keys for the same level of security. Breaking an RSA key requires you to filter a large number. We are pretty good at filtering large numbers and getting better all the time. Breaking an ECDSA key requires you to solve the elliptic curve discrete logarithm problems. This is very difficult. This means that with ECDSA you can get the same level of security as IC but with smaller keys. Smaller keys are better than larger keys for several reasons. Smaller keys have fast algorithm for generating signature because the math involves smaller numbers. Smaller public keys mean smaller certificates and less data to pass around to establish TLS connections. This means quicker connection and faster loading time on websites. And in the optimization path, the process was described in three layers. First is the finite field arithmetic. Then is the ECC arithmetic. The last part is the ECDSA protocol layer, and the optimization of the ESC signature scheme is happening on the second layer. A special code was used. It is simplifying the computation. The optimization. The next part is about the natural sum. It is one of the fastest public key ciphers we know. The signing phrase and verification phrase is described in this part. In these two diagrams, the two open parameters will be used where is a prime integer and is the power of key. This was used for key generation. The security of neutral sum is based on the hardness of the shortest vector problem of the lattice. Unfortunately, most of the digital signature schema following the natural design has been broken. There are three main reasons. Each signature value is a linear combination of the private keys, and the combination coefficients have a public distribution. By a large number of signatures, the attacker can filter off the combination coefficients and obtain the value of some simple function of the private key. The reason 3 is such function can be taken as a function of real number variables. Those methods of the continuous mathematics, for example, the optimization methods, can be used for computation of the private keys. And some improvement on this signature schema. It is on simplifying the computation. The optimization of our neutral sign implementation is doing on the parameter generation. It is mainly done on the high-speed manipulation algorithm based on this algorithm. This can break the problem up into some subproblems of size that is smaller than the original size. So it can reduce the computation and also can reduce the memory use. For our scammer, the attacker can only contrast some complicated function for private keys. So a new parameter was used to generate some large keys, which means the size is larger than before. So it can keep the security of the natural sum than the traditional ones. This is the only signature scammer that was not attacked by other people. Then is the last part, the comparison of these different signature scammers. We do the comparison on the four aspects: the energy consumption, memory cost, length of signature and the keys, and the performance achieved by the implementation. Energy and memory cost of each signature in the same work configuration. It is not surprising that the natural sum module is quite small. It has only one core operation and is therefore rather simple to implement. The ECDSA and the DSA module have a more complex arithmetic. Therefore, a lot of code is required. The IAM estimation seems to account for the memory statistically allocated by the key pair and pre-computed value, such as the big pre-computation table for our ECDSA simulating fixed point methods. I think there is a lot of work need to be done on the neutral sum because it is really fast and the memory saving signature scammer, even though it is not safe than other signature scammers. Then I'll do a quick summary of my presentation. In the first part, I introduced the digital signature, different kind of digital signatures, and there is some prior research on three main signature scammers, which are IC, DSC, and Algamo. There is some recent research on some improvement of the new signature scammers. Finally, I do the comparison on the energy cost and the memory costs on these different kind of signature scammers. This is my presentation. Thank you.